Okay, so welcome back. Now, let's introduce one more rule, and in order to introduce the rule, let's use this as an example. Okay, so now we learned that when you divide numbers with exponents, but they have the same base, you subtract the exponent. So let's apply that in this case. So this would say that we would say x, and then we would subtract top minus bottom. So it would be 4 minus 6. Now what happens when we subtract 6 from 4? We get a negative number. We get x to the negative second power. So what does this mean? Well, let's do it the other way, right? And see what we get. So let's just write it out by just using the definition of an exponent. So if we write it out, we get x times x times x times x over x times x times x times x times x times x. And so again, if we cancel, what happens? We get this cancels with this cancels with this cancels with this one, and this cancels with this one. And what do we end up with? We end up with 1 over x times x, or 1 over x squared. Okay, well, if we take this, because this has to be equal to this, right? It has to be. So guess what? That's the new rule. We find that x to the negative 2 is then equal to 1 over x squared. And so the rule number 3, or the third rule or another rule of exponents, is that when we're dealing with negative exponents, it's x to the negative m is equal to the reciprocal with the positive exponent. Okay? So this is the rule that we can use. Now, one thing you always want to also make sure that if you're asked to simplify an algebraic expression, one of the things that we don't want to see are negative exponents. So we always want to use this rule to help us get positive exponents. We don't want to have negatives anywhere. Okay? So that's where this rule is going to become in handy, is we're going to use it to make sure that we don't have any negative exponents in our final answer. Okay? So let's get to it now. Okay, now, I want to simplify these two expressions, these algebraic expressions, as much as possible, and I want to have positive exponents, okay, in simplified form. Okay, so let's do it. Okay, so now, this is negative, so this is going to equal negative. Now, I'm going to split this up just to make it easier to see. So I get 12 divided by 4, so that's going to be the first one. 12 divided by 4 times, right? And then I'm going to get a over a to the 5th, right? So now this is going to equal negative, well, what's 12 divided by 4? That's 3. So I get negative 3, and then I do a, what? I get a to the 1 minus 5, which gives me negative 3, a to the negative 4th power. Now I'm going to use the reciprocal rule, right? And I'm going to write this as what? Negative 3 over a to the 4th. And that would be my final answer. Okay? Now let's do this one. We're going to do the same thing. So now this one, I'm going to split it up. So I'm going to take care of the coefficients first, right? Divide constants, subtract exponents. So this is going to be 2 divided by 8 times n to the 6th over n to the 3rd times n squared over n to the 3rd. Which is going to equal, now this, I'm going to reduce this, right? I'm going to reduce this as much as possible. So 2 divides both the top and the bottom. So this is going to give me 1/4 times m to the 6 minus 3 power times n to the 2 minus 3 power. And so this is going to give me what? If I simplify this and put this as one fraction, this is going to give me what? 1/4 times m to the third times n to the negative first power. And so now my final answer is going to be what? Equal to, now the m is going to go on the top, and I'm going to put the n in the denominator. So that makes it positive, right? Because I'm going to use the reciprocal here. So this is going to be m to the third divided by 4n. And so this becomes my final answer. M cubed divided by 4n. Now, another thing I can do is, and again, there's another way to get the same answer. So let's go back to this. So right here, what I could do is I could, again, reduce the fraction to 1/4. Now, watch what happens. If you could think of this, I have 3 m's, I'm multiplying 3 m's here, and I'm multiplying 6 m's here. Well, these 3 m's will cancel with 3 of the m's up here, and I'll end up with 3 m's. For this one here, I've got 2 n's here, and I know these 2 n's will cancel with 2 of the n's here. And that'll leave me with just 1 n. And so that gives me the same result. So I end up with what? M to the third times 1/n, which gives me the same result. Okay? Have a great day.